Hello everyone, good morning, good afternoon, good evening, wherever you are in the world. Welcome to this Learn TV session where we're going to be looking at how we can run cognitive services on IoT Edge. Now my name is Jim Bennett, I'm a Senior Cloud Advocate at Microsoft and I'm really excited today because I'm joined by my good friend Marko for this session. Marko, do you want to say hello?
Yes, thank you, Jim. Hi everyone, I am Marko Paloski, Microsoft Learn Student Ambassador coming from North Macedonia. And I'm very glad that Jim will be my teacher tonight and going through this module together. And I cannot wait to start.
Awesome. Thanks, Marko. I'm really excited to have you here with me today. This is going to be a lot of fun.
I hope.
Now, as I said, this is a Microsoft Learn module that we're going to be working through live here today. And you can actually follow along with everything Marko and I are doing. If you go to aka.ms/learn/IoT Edge, you'll be taken to the Microsoft Learn module where we run cognitive services on IoT Edge, and you can follow along with everything that we'll be doing here today. Now, one question that usually comes up with this kind of IoT things, Marko, is hardware. Do you have an IoT device for this?
For this exercise, no, but I have some Raspberries at home. But yeah, we're gonna need this one hardware for this session now.
Well, actually, luckily with this session, we're not going to need an IoT device. Normally with these kind of IoT sessions, we need some kind of device to hack along with, to code up. But this session, we don't need it. This is all about using IoT Edge, which is a way you can run AI workloads on a device. And we're going to use a virtual device for this. So rather than relying on hardware, everything we do today, you can do using a virtual device. And that's what we'll be spinning up, which is great. You don't need any hardware. You can do all of this in the cloud, which makes it easier for us, doesn't it?
Yep, so I'm prepared.
You're all prepared. As long as you've got a cloud account, you're prepared. Yeah. Now, there are some prerequisites for this course. You say you're prepared. There are some prerequisites for this. You need a basic knowledge of Azure IoT Edge, a basic knowledge of Azure IoT Hub, and an active Azure account. Do you have those?
How can we have? I have one active Azure account, but how can we create or receive an Azure account if we don't have?
That's actually a really good question. So if you're a student, we actually have an Azure for Students subscription available to you. You sign up, you validate with a student email address, so your university email address, .edu.ac.uk, .ac.jp, what have you. Sign up, validate with an academic email address, and we give you $100 worth of credit and a free tier of a whole lot of services, and that lasts 12 months. And then what's really cool is every 12 months, we just email you to say, you're still a student, and that renews for another 12 months. And that keeps going all the while you're a student. You can have this $100 a year plus a free tier of services. And you don't need a credit card to sign up for that. If you're not a student, we have a Azure free subscription where you can get $200 of credit that will last you for 30 days, and then a free tier of services for a year after that. Obviously, if you want to go outside that, we then have pay-as-you-go subscriptions that you can use. But if you're a student, the Azure for Student subscription is fantastic. Lots of free credit, lots of free services.
Well, that's a very cool thing for the students and everyone that you can create a free Azure account. And I have another question, which is what exactly is IoT Edge and IoT Hub?
Yeah, another really good question, Marko. So IoT Hub is a way of connecting IoT devices, Internet of Things devices, to the cloud. You can kind of think of it as like a big pipe. You connect devices on one end, the other end connects to whatever other services that you want, and you can send data forward and backwards. So you can send data from the device to the cloud, from the cloud to the device, and IoT Hub manages everything for you. Now, IoT Edge is all about running workloads on IoT devices. So you think about like an AI model. You can train it in the cloud, you can run it in the cloud, and you can send data from an IoT device up to the AI model. Or you can actually take the AI model and run that on an edge device. So you're running it on an IoT device that's closer to your other IoT devices. So one example would be video analytics. You could stream up from a whole lot of cameras around your site to the cloud and run video analytics in the cloud, pay a lot of money for all that. Or you could take the AI models, install those on edge devices running it on the same network as your cameras, analyze all your video data locally, and then just send the results analysis to the cloud. So that's what IoT Edge is all about. It's about running these workloads on the local devices, but then managing it through IoT Hub. So from IoT Hub, you can then say, run this workload, get data. Does that all make sense?
Yep. Now everything is clear.
Awesome. You have the prerequisites. We can go do this. Cool. So there's two learning objectives to this Learn module. So the first one is you get hands-on implementing a cognitive service for performing language detection on an edge device. Now, cognitive services are pre-built AI models. We build them, we test them, we train them in the cloud, and we make them available to you to run, either in the cloud or on edge devices. So you can learn how to implement a cognitive service for doing this on an edge device. And then by the end of this, you'll be able to describe how all the different components and services of a solution like this will work together to solve a problem. And the particular problem is language detection. So those are kind of the two main learning objectives. That's what you're going to learn. And the way we're going to do this is kind of like an agenda for what we're going to work through. We're going to introduce why we might do this, come up with a scenario as to why this might be useful. We're then going to talk about how we're going to implement language detection module on IoT Edge, and then how to configure our IoT Edge devices and IoT Hub. Then we're going to have an exercise, get hands-on and actually configure the Edge device and IoT Hub. Then we're going to talk about how we deploy a cognitive service to an Edge device. Then we're going to get hands-on actually doing it, deploying it. Then hands-on again, and we're going to test it. We're going to show how it all works. And then, just to make sure you're paying attention, Marko, there will be a quiz.
Yeah, I am excited for the quiz and also for the exercises we will see.
Yeah, lots of hands-on stuff, then a quiz to prove you know what you're doing. And then one kind of last exercise is we're going to clean up. Now, this is important. Stay to the end. If you've not cleaned up an Azure resource before, stay to the end, because one of the services that's going to be used here is a paid-for service. And if you just leave that running, that's going to burn through your $100 worth of credit pretty quickly. So stay to the end, and we'll show you how you can clean up your resources so you don't end up keep paying. And then we'll just kind of do a wrap up there. Sounds like a fun hour or so, doesn't it?
Yep, I'm ready to go.
Excellent. So let's think of a scenario why we might want to do this. And the particular one that I want to talk about is a natural disaster type scenario. So if you have a situation where you have a natural disaster, earthquake, fire, flood, volcano, there's a lot of people who need assistance, and the global community will get together and jump on these kind of humanitarian crises. You will get people flying from all over the world. They would come together and they would help fix the problems as much as they can. They would care for people, build temporary shelters, look after people, do the stuff that needs to be done. And it's great the global community comes together, but the problem with the global community is there are language barriers. I mean, I'm an ignorant Englishman. I only speak English. That's it. Marko, what about you? How many languages can you speak?
I speak Macedonian and English.
Macedonian and English. So you are 100% better at languages than I am. It's fantastic.
Yeah.
So imagine a situation where there's an event that happens. I'm first on the ground and I need antibiotics. And Marko, you very kindly shipped me a big bag of antibiotics. But the language of the instructions, the dosage information, it's not going to be in English, is it? It's going to be in Macedonian. And does Macedonian even use the same alphabet as English?
No, it uses Cyrillics.
Yeah, so Macedonian uses the Cyrillic alphabet. English uses the Latin alphabet. And so I'm not even going to be able to even read what's on the label back to you. If I give you a call, I'm not even going to be able to read this to you.
Yeah.
In fact, I'm not even going to know to give Marko a call because it's characters I can't identify. The same is if it was Chinese characters. In my ignorance, I may not know whether it's simplified Chinese, Cantonese, a whole lot of different languages I may not be able to read. And so if we can do language detection, I can very quickly see the language and then contact the right person for help. Now, we can do this in the cloud. We can send the language up to the cloud and do analytics. But what things don't usually work in disaster scenarios?
Well, in disaster scenarios, the infrastructure is down, the electricity, internet, every connection that's...
Yeah, all these things go down, they don't work. So I may not be able to connect to the internet. So ideally, what I want to do is better deploy a language detection model to a device and then run that offline. And that's kind of what we're trying to do here. Be able to run this in an offline type way. So here's the kind of architecture of what we're going to build. So in the cloud, we're going to have a language detection container that's available via the Azure Container Registry. And then we're going to deploy that to an IoT Edge module that runs on-premise. And it's this IoT Edge module we can take to our medicine, we can do language detection, and then if necessary, send the data up to IoT Hub, send the results. But the main thing is we take it from the cloud, deploy it to an IoT Edge module on-premise, and run with it. Does this architecture look good to you?
Well, it looks interesting, but I have some questions here I don't understand in the infrastructure.
Yeah.
I would like us to ask you what's exactly is a container and Azure Container Registry.
Really good question. Really good question. So the idea of a container is to isolate an application. So you can literally download an application that will run with everything it needs. So the original problem that containers were designed to solve were, you know, the kind of thing where you install a framework and then you install an application that uses it, and then you update the framework, install a new application, and the first application breaks because it's relying on an older version of the framework. You've had that, haven't you?
Yeah. I don't know if anyone doesn't have this situation.
Everyone has. I guess a lot with embedded software development. You install a tool chain and it breaks other tool chains. The idea of a container is it runs everything in isolation. So it virtualizes the operating system. It uses just kind of the core kernel of your operating system. And then on top of that, it installs all the libraries you need to run your code. So you can have one container with your old version of the framework and your first application, another container with a new version of the framework, your second application, and they would run in isolation. They wouldn't know about each other. It would just work. And then Azure Container Registry is like a package manager for containers. You've used things like pip, npm, NuGet, things like that before? Yeah, it's basically like that. But instead of pip install some software, you install a package. So you go to the container registry, you say, I want a container, and you can choose the version of it, you download that container, and you run it. So it's kind of a nice way to host containers. And there's public ones or there's private ones for you.
So let's say that these containers are something similar like virtual machines. Not exactly, but in this way.
Yeah, same, but different. It's similar. A virtual machine will virtualize the process and the memory, whereas a container virtualizes the operating system.
Yeah.
So it's kind of in a virtual machine you can say how many processes you want, how much RAM you want. Container doesn't have that. It's just the container runs on a virtual version of the operating system, but kind of similar in that you can download it and run it, and it's all isolated. Yeah.
Yeah. And what exactly is IoT Edge module?
Yeah, another good question. So an IoT Edge module is an IoT device running IoT Edge. So there's the IoT Edge runtime, which kind of sits there and orchestrates everything. And the Edge runtime connects to IoT Hub, gets told what containers it needs to install. It'll then download the containers from the Azure Container Registry and then run those containers. And so it's the device that we're going to take offline. Online, we're going to connect it to the cloud. The Azure IoT Edge runtime will know that it needs to install the language detection container. Download that container, it'll install it, it'll run it on the Edge module, the actual physical device, and then we can take that offline. So it is the IoT device that's running our containers.
Now it's better. Yeah, I understand this concept.
Cool. All makes sense. Excellent. So let's kind of talk about how we're going to implement this whole language detection module running on IoT Edge. And we're going to do it by running Azure Cognitive Services on an Edge device. So we're going to use an Azure Cognitive Service, but rather than run it in the cloud, we're going to run it on the Edge device. And so the goals of what we're building is it needs to run offline. Yeah, but as you said, there's no infrastructure in a disaster area, so it needs to run offline. We also want to run using the standard Cognitive Services APIs. So if you run a cognitive service in a container, the API is the same. So when you have a cognitive service in the cloud, there's a REST API you can call, and there's a load of SDKs, Java, JavaScript, Python, .NET, a load of SDKs you can use to access that cognitive service. If you run that cognitive service in a container, it uses the exact same APIs. So what that means is we can have a team of people building an application for language detection. They can test it against the cognitive service running in the cloud, and then when they come to deploy it, instead of pointing it at the cloud, they point it at the Edge device. And then we can run on our own isolated networks running without internet access, accessing the container. So we want to run using the standard APIs. And so in this case, we're focusing on language detection.
So all these APIs and SDKs are free for use, right?
Yep, totally free for use. You obviously you pay for the use of the cognitive service, and we'll look at the cost of that later. But the SDKs are open source; they're freely available to use. You don't have to sign up for anything to get hold of the SDKs. They're all there, freely available to use.
Cool.
So the steps we're going to do overall is we're going to start by creating an IoT Hub, then create an IoT Edge device, then create an Azure resource for text analytics, and then configure the language detection container to work with that resource. Now, the reason for doing this, the reason we have to set up a text analytics resource and a language detection container is money. It's basically money. Yeah, we all love money. Now, so the way you use cognitive services is you choose a tier that you want, and that gives you a certain number of calls for a certain price. And we have a free tier, so you can get a certain number of calls to the text analytics service for free every month. And if you go over that, you just don't get any results back. If you want to do more calls, you pay a certain amount. More calls, you pay a certain amount. Now with the container, it's exactly the same. You still pay the same for the container. So you get so many for free, so many at certain costs, so many at a higher cost. But for the container to know which one you've signed up for, it has to talk to the cloud. So it will need to talk to a text analytics resource and find out what the billing is. So all the language detection stuff happens in the container, but every now and again it has to call home to make sure that you're within your billing limits, you're within what you're paying for. So that's why we have to create the resource and the language detection container. Then we have to set up the container to IoT Edge, and then we're going to test it out. And then we're going to clean up right at the end. Sounds like a fun set of steps, doesn't it?
Yeah, let's start.
Let's start. So let's take the first section. Let's look at configuring Hub and IoT Edge. And to make this happen, we need to configure 4 components. We need to configure the resource group, the IoT Hub, the device identity, and the virtual machine.
Resource group and device identity. What exactly are those?
Good question. Good question. So a resource group is a logical grouping of resources. So anything you spin up in Azure, a database, a virtual machine, a website, an AI service, is what's called a resource. And you group these together in a resource group. Now it's up to you how you group them, but you create a resource group and you say, this service goes in this resource group. This service goes in this resource group. And then what you can do is you can manage the resource group as one whole entity. So if you want to delete everything, you delete the resource group, and that will delete every single resource inside that group. So every resource has to belong to a group. When the group goes, the resource grows. Now, what I'd like to do is I like to put all the resources for a project in one group. So something like this, the hub, the edge device, the cognitive service, I would put that all in one resource group so that when I'm done, I can delete that resource group. And that's the same I do for all my projects. One resource group with everything in there. And I know I can manage that resource group as a whole, which is pretty cool.
So this is like one object and it's more or less used for structuring your projects or something like that?
Basically, yes. It's one object that contains all your other objects, and you can manage that object as a whole. And let's say I do it one resource group per project. Obviously, it's up to you how you do it. I probably wouldn't advise having one resource group for IoT hubs and one resource group for cognitive services, because then you lose track of what's what. But sometimes you may want multiple resource groups for a project. If you're rolling something out globally, you may have like an EMEA resource group and an Americas resource group and an APAC resource group. Kind of, it's up to you how you structure it. There's no rules, but do it in a way that makes sense for you. And the other question was device identity.
Yes.
Device identity is all about security. So there used to be a joke that the S in IoT stands for security. Obviously, there is no S in IoT because IoT used to not be secure. With Azure, we make sure IoT is secure. So you can't just connect a device to an IoT hub. The device has to be authenticated. IoT hub has to know about that device. So you define a device identity that IoT hub knows about. You give that device identity to the IoT Edge device, and the IoT Edge device is allowed to connect. Without the device identity, you can't connect. So it's how we manage security. And we'll see later on how we create one and how we use it.
Yeah. Okay.
Cool. So the steps we're going to work through is we're going to create the resource group. We're then going to create our IoT Edge device, and we're going to use a virtual machine rather than a physical device for this one. We're going to create our IoT hub. We're then going to create the device identity inside IoT hub to register the Edge device, and then we're going to configure the Edge device to connect to IoT hub. And that's kind of our first step, is to get our hub and Edge device connected. You ready to do this?
Yep, I'm waiting.
Excellent. So let's actually do it. Let's get hands on do this. Yay.
The best part.
The best part, actually doing it. Yes. Have you seen this before?
Yes, this is the Azure portal.
That's correct, the Azure portal. Yeah, so this is a UI for Azure. This is where you can manage your resources, your resource groups, create new resources, a whole lot of different capabilities to visualize and manage everything you do. Now, we also have a way you can create Azure resources called the Azure CLI, which is a command line interface which runs in the terminal. And I can actually do that from inside the Azure portal. So I'm just going to, if I just zoom in here, you see this little command prompt icon, Cloud Shell? If I click that, that will spin up down here a Cloud Shell, which is a terminal that runs inside my Azure subscription. So it's logged in as me. It's logged in using my default subscription, and I can do things to manage resources. Here I am inside the Cloud Shell.
Oh, this looks very good. I can see there that this is Bash, but you have other options as well?
Yeah, there's Bash and PowerShell.
PowerShell, okay.
Yeah, so you can choose which one you prefer. I prefer Bash, so I use Bash. And you see here it says type AZ to use the Azure CLI.
Okay.
I type AZ. This will give me the Azure CLI. So here's everything here, all the commands I can run to do the Azure
main
CLI.
command, yeah.
All the main commands. Now, this Azure CLI, by default, doesn't give you everything that you can do in Azure. It gives you kind of the core things that you can do. And there's a whole load of extensions that you can run to improve the power of this, to add more capabilities. So I'm just going to come here, paste in the command, AZ extension add -- name Azure IoT. And that will install, it's already installed, excellent. That will install the Azure IoT extension, which gives me a whole lot more capabilities for what I can do with IoT. So this kind of means I can do a load of stuff, but it means that as new IoT services are released, they can update the extension rather than having to rely on the main CLI to be updated. So a lot of these extra extensions, and this is the one we need for IoT.
Some way of packaging, right? Some way, yeah. This is IoT package, for example.
Yeah, basically, yeah. It's packages for the Azure CLI.
Very
so
fast.
This is the IoT one, and there's obviously lots more for different capabilities, which is pretty cool. Okay, next thing I'm going to do is a little trick that I like to do. So when you work through a lot of these Microsoft Learn modules, there's instructions on the CLI, and there'll be things you have to replace. So it'll be a command to create a resource group and then you have to put in your resource group name. Or there's a command to do something and you have to put in the resource group name. Or there's a command to do something, you have to put in the IoT Hub name. Now, I keep forgetting the names that I pick. I will create a resource group and I'll call it something, and then I'll start typing the next command and I've completely forgotten the name of my resource group. So what I like to do is export a couple of environment variables for the resource group, in this case the IoT Hub, and that way whenever I do something I just put $resource group or $IoT Hub, and that swaps in the name, and that just makes my life a lot easier.
This is a good trick, useful trick.
It is a useful trick, yes.
Yeah.
And another top trick, actually, another top tip, this Cloud Shell is persisted. So anything that I configure, any files I create, when I close the Cloud Shell and reopen it, they're there. So I can create a .bashrc, basically a bash resource file, where I export some environment variables. So I could export, say, 3 different resource group environment variables for different projects. Resource group project 1, resource group project 2, or what have you. I can export a whole of environment variables for different projects, and that way when I come to do stuff, I don't have to remember, what did I call that resource group? What did I call that hub? I can just put IoT Hub project 1 or whatever's the name of my project. So I can save that in my .bashrc file. So top tip.
This is saved actually on your account, right?
Well, not at the moment because I've just run export now, but I could edit a file and that would save it in my account. Yes. So if I add these to my profile file, then I can close the Cloud Shell, relaunch it, and I would get those environment variables again. So it's kind of a good way to save you remembering the names. You just create the environment variables.
Cool thing.
Yeah, it's a little tip I like. So first thing we'll do is I'll actually create the resource group. I'm going to run this command here, AZ group create -- name, and there's my $resource group. So my resource group is called Learn TV. I don't have to remember about the name.
Yeah.
I can put that there. Yeah. Now, this one here, this -- location. Have you come across the locations in Azure before, Marko?
Yeah, I have seen a few, most probably the Europe versions, but I know that there are a lot of them.
Yes, there are, I think, 60 that are either fully online or we've announced. And each region is multiple data centers. So Azure isn't like one building. It's not just like, here's one building with all our computers in it. We have 60 regions. Each region is multiple data centers. And these data centers are multiple square miles in size. And it's designed so that you can deploy your code anywhere in the world. You've got full redundancy so that if a power station goes down, takes out a data center, the other one's still running. If somebody, I don't know, a boat doing some dredging and accidentally cuts an internet cable, which has happened. You just connect to different regions and allows you to deploy your code where you want. And ideally, you want to choose the closest location to you because speed of light is fast, but not perfect. And you want to make sure that all your resources are in the same location unless you have a particular reason not to. Because if you start shipping lots of data from one region to another, that costs you money. Mm-hmm. So it's just choose where in the world it is. I've gone for one on the east coast of the US. Yeah.
Okay.
Okay. So that's the resource group. So now we're going to create our IoT Edge device. And this is going to be a virtual machine. Now, before I can create it, I have to run a command to agree the terms and conditions, because there's some terms and conditions for this. So I run a command to agree the terms and conditions for a particular image. And then I'm going to run a command to actually create the virtual machine.
So what I can see from this command, we are using Ubuntu operating system, right?
That's correct, yes. So this virtual machine, the command here, azvm create a virtual machine in our resource group. It's named Edge VM. This is an internal name. This isn't a public name. It's an internal name. The image is the Microsoft IoT Edge VM Ubuntu 16.04 Edge runtime only latest. So this is the latest image we have that runs Ubuntu 16.04. And this comes pre-installed with Azure IoT Edge. So all the IoT Edge runtime is pre-installed on there. Plus, there's a helper script that will allow us to configure everything a lot easier. So this is a pre-packaged IoT Edge virtual machine. And then created with an admin username of Azure user. And then we're generating SSH keys. So this will create the SSH keys we need to log in and authenticate and save those to my Cloud Shell. So anytime I can relaunch the Cloud Shell, and then I'll be able to log in with my SSH keys. So I can log in without a password.
Yeah, that's a nice thing to do.
Yeah, it's pretty useful. This is going to sit here. This is going to run, and in a few seconds, this should actually end up creating the virtual machine. So while that's running, I'm going to flip to another Azure window, launch another Cloud Shell. No, it hasn't finished yet.
Need some little time.
Yeah, so launch another Cloud Shell. I'm going to re-export my environment variables again because I didn't save them to my profile, so I have to do them every session. And I'm going to start creating the IoT Hub. So I've got another command here. Create my IoT Hub. So that's now creating, still create the VM. So this is AZ IoT Hub create, passing in my resource group, passing in my IoT Hub, so my environment variables. Create that. Now we've got a SKU of F1. Do you know what F1 is?
Formula One?
Yes, this is the IoT Hub Formula One edition, as driven by Lewis Hamilton. No, so the SKU is the tier. It's the amount of whatever you get and how much you pay for it. So each Azure service potentially has one or more tiers, and that has got the amount of power the thing has and a cost. So F stands for free. Do we like free?
Yeah, we all love free.
We love free. So F1 is our free tier. So that means we don't pay for this IoT Hub. It can process 8,000 messages a day. And after that, no more messages get through. They just get binned. But that's still, 8,000 a day is pretty good for
pretty a free big tier. Number. And this is only with using one resource, right? You can only use in one resource this free tier.
Yes, only one. Yeah. Otherwise, you can spin up 1,000 of these things.
Yeah. That doesn't make sense.
So per subscription, you're only allowed one free tier of each resource. So that's a free tier, so 8,000 messages. It's more than enough.
Yeah.
And all we're going to be really using IoT Hub for is to configure our edge device. So we're not going to go over that limit anywhere near it. But it's quite nice. So unless you need lots of real-time data all day, you'll be able to have one IoT device running for free. I've got devices that will report once an hour, and so I can have 10 devices running, and I still don't even get anywhere near my 8,000 limit, which is pretty cool. This last one, partition count. This is how many listeners are listening to our data. We don't really care about this too much, but if we had a lot of data coming in, we may want lots of partitions to pick up the data, but we don't care about that. So that's now running, that's now creating. And while that's done, you'll see we have now created our virtual machine. That's spun up, that's running. We've got a public IP address that we can use to access it, and we're we're away and going. And this virtual machine will be our virtual edge device.
Cool.
Cool. And so we go back to my IoT hub. That's now
It's already
complete.
done.
All done. Notice that here's our tier 3.
Free.
So we've got our edge device, we've got our IoT hub, but now we have to get the two talking to each other. And the first step of doing that is to create one of these device identities that we talked about before. So let me just run a command to do that. So this says IoT hub device identity. Oh, so quick.
Fast. Yeah.
So fast.
Formula 1.
Yeah, IoT hub device identity creates. So that creates a device identity in our IoT hub with a device ID of my edge device, and it's edge enabled. So it's an IoT edge device. It's called my edge device. We have a device identity created. So the IoT hub now knows there's got a device called my edge device. So now we need to tell the IoT edge device the credentials for that, the device needs the secret information so that it can then connect. So what we do, we run another command. Azure IoT hub device identity connection string show, and that will show the connection string for my edge device on my hub. And this is our connection string here. So the connection string is made up of 3 parts. The host name. So our IoT hub has to have a unique name. I've called it Learn TV GMB because the name of the IoT hub gets put into a URL. So the actual end URL that the device connects to is learntv.azure-devices.net. And so I have to have a unique name for my IoT hub because that becomes part of this host name. So
it's public.
It's public, so anything can connect to it. Yeah. My device ID is my edge device. And then the shared access key, this is my secret. This is my secret piece of information that allows my device to connect. So anyone can try to connect to learntvgmb.azure-devices.net, but unless it's got a device ID for a known device and a shared access key that matches the one expected for the device ID, the connection will be rejected. So this is how I can connect my edge device in an authenticated, secure way. And these connection strings are device specific and they can be rolled. So if somebody finds out my connection string, I can just change it. There's actually 2 connection strings per device. So if somebody finds one, I can flip it over to the second one, regenerate the first one. So every now and again, I can roll my connection strings to keep them secure, which is quite nice.
Yeah.
So now we have to tell the virtual machine about the connection string. So give me a second while I just edit the command to do this. Let me go back here. Copy
the connection string.
Copy the connection string. Yeah, paste it. So what this command here does, this will connect to a virtual machine and run a command. So it goes to our Edge VM in our resource group and runs the script /etc/IoTEdge/config-edge.sh and passes the connection string in. And what this script will do is this script connects to the virtual machine. It'll run a helper script that's on there, pass in the device identity, and that will then configure IoT Edge to use that device identity and restart IoT Edge. So when this command is finished, the virtual machine will then be connected to the IoT hub.
So if someone doesn't use this script, he will need to do this manually, add the connection string in the virtual machine, the configuration file, right?
Yes. Yeah. When it's finished, we'll actually log into the virtual machine and we'll see what someone has to do to do this manually. Yeah. But while it's doing that, I'm just going to go here and hide this Cloud Shell. If I go to my resource groups in the portal, this is the Learn TV one that we created. And in this resource group, you'll see we have a load of resources. So this is the virtual machine, and this is the IoT hub. So what you're saying about is one object. It's one object, my resource group, that contains my virtual machine, the hard disk of the virtual machine, the network information for the virtual machine, and my IoT hub. So it's all here in one place. If I actually go to my IoT hub, go down here to device management, go to IoT Edge devices, and there's our Edge device.
Yep.
So that's the one there that's expecting. Cool. Our script's now run, so our Edge device should now be connected. So let's just click on it.
Okay.
Yeah, running. So the Edge agent, the thing that keeps going, that's running.
Perfect.
Yes. So saying about configuring the connection string, what I'm going to do is just going to connect the device.
Okay.
So where's the IP address? Here it is here. So get SSH as the Azure user into the VM. Just wants to check that
yes.
is what I'm expecting to connect to. Yes, there we go. And that's logged in. I haven't used my password because it uses the SSH keys that were created. So I'm now on the virtual machine. If I run the command IoT Edge list, that will list the what's running inside the IoT Edge agent, and that's just the Edge agent. The thing that keeps it working, that's running. That's it. Now, saying about that connection string, there is a file. Inside the /etc IoT Edge, it's a config.yaml file. Oh, I can't spell nano.
Yeah, no.
Sudo now. Sudo nano. So this is the configuration file for IoT Edge. And down here, manual provisioning configuration.
Device string, yeah.
Yeah, that's the connection string. So if you were to do this manually, if you were to install IoT Edge on a device of your own, you have to open up this YAML file, set this connection string, and then restart IoT Edge. So that's what that script did. It's just a helper, just makes our life a little bit easier.
Yep, and faster.
And faster.
More time.
Yes, we like things that are fast. So this is now running. This is connected. We've done the exercise. We've configured IoT Hub and IoT Edge. Pretty cool, hey?
And that was really fast. I mean, click, click, click.
Click, click, done. A few commands and away we go.
Yeah.
Cool. So now let's talk about the next step. Talk about how we can deploy the cognitive service to the Edge device. So this is where we're going to create a text analytics resource and then create and deploy the language detection module to IoT Edge. So two things we have to create is the text analytics resource and then the Edge module. So we need to create the resource for the billing and then create the Edge module. And when we do create the Edge module, we have to pass it some configuration information. One, a license agreement, we have to agree to it. And then we have to pass in the billing endpoint and the API key from our text analytics resource so that it knows how to do the billing appropriately. Yep. So what we're going to do, we're going to create the text resource, configure the language detection model, and deploy it. Sounds good?
Yeah, it sounds interesting. Some new things.
Yeah, so let's do it. Let's actually do an exercise.
Jump in.
Jump right in. So what I'm going to do first is create the text analytics resource, and I'm going to do it from the Azure portal rather than the CLI, just because I can. So I'll click Create a Resource. Under AI and Machine Learning, we have text analytics.
So this marketplace that is in Azure, it's all the operating system application are here just with one click or installation, something like that?
Basically, yes. Yeah. So everything you create in Azure exists in this marketplace, and it contains services from Microsoft. So Azure Functions, Microsoft AI Services, Azure App Service, virtual machines, all that kind of stuff. So stuff from Microsoft is here, but also stuff from third parties. So if you happen to have built a service that runs on Azure, you can actually sell it on the marketplace. And it's obviously paid for resources, free resources. It's all here. You literally choose the one you want.
So it's pretty big marketplace, super marketplace.
Oh, it is enormous. Actually, a few years ago, a friend of mine was giving a talk, like an intro to Azure talk at a meetup. And she was saying that you don't want to scroll down through the whole list of services, because if you do, by the time you get to the bottom, we've probably added a new one. Because it's a massive list and it's constantly growing. So yeah, so many things you can do. It's just click, click, deploy, so many different resources. That's again why we need extensions for the Azure CLI, because where people are adding resources, they can build their own extensions to manage their own resources. It's pretty cool. So we need to create this text analytics. We need to give it a name. Call this one Learn TV Jim B. Choose my subscription. Choose my location, where in the world. So I was using East US 2 before, so I'm going to use East US 2 again. So same location. Pricing tier. So again, pricing.
Formula 0.
Yes, Formula 0, the free one. 5,000 transactions per 30 days. So that's pretty good, really. That's quite a lot for free. 5,000 transactions a month for free. So this is free. The IoT Hub is free. The IoT Edge device is not free. So that you have to pay for that, but you pay pretty much per second billing. So yeah, it'll be a certain price a month, but if you only got it up for an hour, you only pay for an hour, which is pretty cool. Yeah. So this is free, and then we want to pick the same resource group that we're in before. So we're just going to create this in the same resource group. Where you saw before, we had the virtual machine and all the VM bits and the hub in one resource group. This resource will appear in that resource group. Click create, and that will go off. Validate, make sure everything there is good. Submit it for deployment.
So it's pretty fast.
Yeah, so deployment's already started, and these are...
Oh, it's done.
There we go. Deployment's done. So it is pretty quick. Now I'll click on the text analytics resource, and here's all the details for it. If I go to keys and endpoint under resource management, it gives me my keys and my endpoint. So this is what we're going to use for billing when we run the container. Because obviously in the container, it's going to be billing us based off here. We've chosen free, 5,000 every 30 days. So if we use our 5,000, that we need to do more, the container needs to call back to say, oh, what tier are they still on the free tier? Are they on a better tier? We could be using some of the free ones now. So if the containers were using it and we're using it directly, we could easily exceed our billing limits. So the container does need to call back every now and again for the billing. Just top tips to know. So although we're saying about offline, this is not fully offline. Every now and again it has to call back for the billing.
From time to time, it needs to check,
Yeah, not for the language detection. All that happens locally, but just every now and again needs to do a billing call. So that's our text analytics resource. That's created. I'm going to zip back over here. I'm just going to hide the CLI here. I'm going to create a resource here. And for this one, type text analytics again. But this time I want the Edge module for language detection. So this is a pre-built IoT Edge module. It needs Linux x64 to run. So any Linux x64 device. And this creates our Edge module. And this is really cool. This is really cool because this does everything for us.
So this is pre-built for the Edge device. I mean, for the hardware, if we have for some kind of hardware, let's say.
Yeah. Anything that's running Linux x64, you can deploy this to it. And what's cool is this does all the hard work for deploying. So it's got my subscription. It's got my hub. I click my define device. I choose the My Edge device that we created and select that. And I can actually manage which device, and this will automatically set up the deployment for me.
Wow. And you also have option if you have more Edge device, that means deploy at scale?
Yeah, so deploy at scale means we deploy to multiple devices. So if we had, say, 100 devices in a factory doing video analytics, we could deploy to all those devices at once. It's pretty cool.
Wow, with one click.
Pretty much, yeah. So once we've done this, once we've said what way we want to deploy it, we need to do a little bit of configuration. So this is the module that we want to deploy, the Edge module language detection text analytics.
Okay.
This is what we want to deploy. If I click on it, there are some settings to set. So the first one is the environment variables. So when the container starts up, it will read these values and use them. And these are the three settings we talked about earlier. Do we accept the end user license agreement? Yes.
We accept.
Billing endpoint and API key. And those come from the text analytics resource. Copy the endpoint. Drop that in there. And then copy my API key. Drop that in there. So that's configures it. So when it starts up, it's got the right billing information. And the next thing to configure is the container create options. So when you run these containers, they have applications running inside them. And these applications might be web-based applications or internet-based applications that are listening on a port. And so actually the Edge device, the language detection container listens on port 5000. So it's sitting there running inside the container, listening on port 5000. Now, we need to make sure that port 5000 is available outside the container. So the moment it's configured so that any requests to port 5000 are directed from when you hit the outside the container at port 5000, it directs it to what's listening inside the container at port 5000. But what's not configured is like a firewall to make sure you're allowed through. And so I'm just going to paste in a slight change here. We want to say that, yes, we do want any hits to 5000 from the outside to then call port 5000 on the inside, which is where the container is listening. But we actually want 5000 to be open. We need to make sure the Edge module is actually listening on 5000. So you need to make just a small tweak here.
So by default, this is not from the outside connections to this port, let's say, it's not possible.
Yeah, it's all blocked. So we need to expose it. We expose the port. And then now it's exposed. When we hit 5,000, when we hit port 5,000 on the virtual machine, the container exposes that port. That then gets sent to port 5,000 on the application running inside the container, which is the Edge module. So we could actually have multiple cognitive service containers all running on this Edge module, all listening on port 5,000, but we would just change the mappings. So we'd have 5,001 mapped to 5,000 for one cognitive service, and 5,002 mapped to 5,000. So you have multiple applications with this listening on the same port in the container, but exposed to a different port outside. So you update that, click review and create, and that creates this deployment manifest, which is a JSON document that describes what we want to deploy. And so this is saying we're deploying the Azure Cognitive Services language module from the Microsoft container registry. There's our configuration. We accept the license agreement. Here's our billing information, the stuff we want to deploy. And literally, I could click create now and create that, or I could download this JSON file and use this to deploy later if I wanted to. Say I wanted to put this in source code control to track what I deployed, I could do that with this file. There's an extension in VS Code where I can just drop this file in and use it to deploy. And I can use this to deploy to any device. If I click create now, it deployed to the device we've chosen, but I could then take this JSON document and manually deploy to a different device. It's quite nice.
A lot of options to use.
A lot of options, but right now I'm going to click create, and it's going to happen.
And it's already updated.
Yep. So here we go. IoT Edge module count of 3, because there's 3 IoT Edge modules. There's the Edge agent that orchestrates it. There's a hub that allows it to talk to IoT Hub, and there is
service.
The language detection container. So it's specified in deployment, but it's not reported by the device yet. The reason being is that it takes time for it to download these containers. So the Edge agent's been told, here's a container. It's now got to connect the container registry and download that container. And it's going to be fast because it's inside an Azure region. But if you're doing this locally, it might be slower. So for example, I've got the hands-on lab I've worked through a few times, which downloads a YOLO model, an image detection model, to a Jetson Nano device. And that can take 10, 15 minutes to download multiple gigabytes of data for the container. Obviously, the internet speeds will vary and all that. But this is going to slowly take time and slowly download everything.
But this download only happens in the first place, right? When you configure or change something new, then it's just happening. Otherwise, it will be run. Okay, yeah. Yeah.
So once the download's done, actually, no, let's go for this cloud show here. Once the download's done, then it won't need to download again. That's it. We can literally, obviously, can't do with the VM, but in a physical device, we then unplug it from the internet, and everything's installed. So if I go back to my VM and run IoT Edge list,
come on.
There you go. So it's now got the Edge agent, the Edge Hub is running.
Except the service. Oh, now it's the service also.
And now it's up. Now the service is running. And I go back here, refresh this.
Yes.
Yes. It's all running. Cool. So do you think we're able to test this now?
Let's give it a try. I'm not sure.
Well, actually, the answer is no. The answer is no. We can't test this yet. Because
the virtual machine is not accessible from outside.
Because the virtual machine is not accessible from outside. Yes. It's all about security. Azure is very big on security. Our IoT services are secure. Our VMs are secure. So if I go to our Edge virtual machine and go to the networking setup here, we have what's called inbound port rules. So when you create a VM, by default, we don't let you connect except in the ways that you said you want to connect. So this one here, for example, we've got a port rule that says, if I connect on port 22, which is SSH connection, we're allowed. It's not port 22. The virtual network and the Azure load balancing, which kind of internal stuff, is allowed. Otherwise, deny. Because remember, this is listed on port 5000. Port 5000 is denied. There is no rule for port 5000. So what we have to do is we have to add an inbound port rule. So click this here. Let's go to the basic version and say on port 5000, we want to allow a connection. I'll just name this one port 5000. There we go. This is where we want to allow a connection. And now create a rule. to allow it. So then what happens when we connect on port 5000, it'll work through these rules in priority order. So hit the first rule. Are we port 22? No. Hit the second rule. Are we port 5000?
Yeah.
Yes.
Hello. So in Azure, every every service that has a public IP address by default is not accessible from outside, right?
Yeah. So when you if you create a virtual machine manually, you actually have to choose which ports are available from outside. So the idea being that you only make the bare minimum accessible, and if you have a machine that doesn't need access to the outside world, you can just turn off access because you have these virtual networks. You can set up a virtual network and say any machine on this one virtual network can talk to each other, but nobody outside the virtual network can talk. So there's a whole lot of ways to configure security, but everything by default is secure. That's just how it works.
Well, yeah, that's a pretty good practice for security.
Yes, you want to be the most secure as you can possible.
Yeah.
So now if I go here, if I paste this in, and we're hitting a port 5000, and I hit this, bang, your Azure Content Service container is up and running. So obviously I'm doing this over the internet because it's a virtual machine, but if I was in the offline scenario we talked about, this was running on an IoT Edge device, maybe I have like an internal network, configured via tethering to a phone or something, and I can hit the IP address without an internet call, and I'll be there, and I'll get my cognitive service. So we've got it running. Should we test it? Should we see if it works? Should we play with it?
Yeah, yes. We should try.
Now, so rather than build an application that calls this to kind of just make things a bit faster for this Learn module, we're going to use what's called the Swagger documentation. So Swagger is a way of defining a REST API and providing documentation and a way to actually test out the API. So this Swagger documentation, it's automatically there for this container, and it gives you what's available. So you can call a get on status to find the status of it, and you can see there's a detect language, there's a version 2 API, and a detect language version 3 API. So these are all the REST APIs that are supported, and obviously we could use the SDKs if we wanted to. But what I can do is, if I expand this one, this is the documentation for the detect language API. It defines the input, which is an array of documents describing text to be analyzed, and gives you a sample. Gives you the other options you can specify, show stats or the model version. It will then give you the example response and an example for that call. So it's kind of well documented what goes in, what comes out, and any errors that you might get. And not only is it documented, but you see this try it out button? What do you think it does?
Let's testing this documentation.
Basically, yes, it allows us to run the API via this documentation. So I'm going to just take a bit of text over here.
Oh, so you can
this text box.
Input yours, not just test it.
Not just test it, yeah. So I can go here. Come on, copy that. Come on.
Oh, yeah, here it is.
There we go. Yeah, so I've pasted some documents. Okay, I've got some text in there. Okay, and then I click the big blue X button, and that will run this. First thing it gives us is a curl command. So curl is a way of hitting REST APIs from the command line. It actually gives us the curl command that we've run. So we could use this later if you wanted to run exactly the same data, and gives us a response. So the first language, what language is this?
This is French.
It is. It means hello, my friend in French. And what's this one here?
Zdravo, priятele.
And
Macedonian. Yeah, it's Macedonian, yeah.
What's that in English?
Well, in English, it's hello, my friend.
Hello, my friend.
Hello,
excellent.
friend. Yeah.
So we come down here, and it's detected French and Macedonian.
Macedonian, yeah. Wow, it's
pretty cool, hey?
Yeah, so, definitely.
So what we could do is we could use this. We could then take whatever's written on the antibiotics that you've shipped me. I could run it through this, and it will say, "Yep, that's Macedonian." So right, and now I need to call Marko for translation. Or if it was in, say, Hindi, I could then phone somebody who's a Hindi speaker to help me with the translation, to help with the dosage. Or if it was in Portuguese, I could again talk to a Portuguese speaker. Kind of this can help me detect the language. And so this whole thing will run offline. So we could do this without the infrastructure and run it offline. As I said, this is the curl statement here. So I can actually take this curl command. I'm going to copy that and go back over here into my Cloud Shell just to prove it still works.
In the bash.
Paste that in there in the Cloud Shell, and bang, here's the same result. French and Macedonian.
Perfect. I mean,
pretty cool, isn't it?
Yeah.
So that is that. Oh, that's that exercise, and that exercise. We have got it working, and we've tested it.
Yeah.
Do you know what comes next?
Oh, how can I forget?
The quiz. Let's see if you were listening.
Yeah.
So question 1. The ability to deploy a cognitive service as an IoT Edge device in a container provides which advantage? Is it A, cognitive services can run faster, B, ability to run online, or C, ability to run offline?
Well, I'm not sure for the first one if the services can run faster. I mean, that's depending on a lot of situations and stuff. The ability to run online, I mean, that's not something special, but the answer is from C, that the ability to run offline, I mean, most of the time offline, not all the time.
That's correct. Yes, most of the time this one's offline. In general, IoT Edge is completely offline unless your service needs to call back the cloud.
Like something to.
Now, your point about A, can they run faster? I mean, they probably won't be able to run faster because we have a cloud and people using it on IoT Edge devices don't have a cloud, a portable cloud, but it may appear to run faster because of network time. So for you to take the data, make a call to the cognitive service in the cloud, get the results back, it may be faster to do that on the edge because the network hop is less. Especially things like image. If you're shipping a lot of image data to the cloud, that network hop can take a lot of time. Mm-hmm. So it may appear to run faster, but it probably isn't actually doing the running faster. It's just the network hop slower, faster. Question 2. For a cognitive service, where does the training take place? A on the edge, B in the cloud, C on premise.
Well, I think A and C are the same, but the answer is B in the cloud, because that's in the beginning that we do the training and then deploy to the edge device.
Yes, that's correct. So it's the cognitive services are trained in the cloud to take advantage of all the GPUs and all the power in the cloud, and then then you use them either in the cloud or the edge. So this is trained in the cloud.
In the cloud.
And last question, what is the function of the Azure Container Registry? Is it A, storing and managing container images, B, storing and managing images, or C, storing and managing services?
So I guess I asked a good question in the beginning. The answer is for under A, storing and managing container images.
That's right. Yeah, it's like a package manager type thing for container images. Awesome. Right. The one final exercise, the important one, the cleanup. Yeah. This is important to save spending money because, as I said, the text analytics is free. The Azure Hub is free. The IoT Hub is free, but the virtual machine is not free. So I'm going to go back to my resource group. Here it is here. And you'll see in the resource group, we've got the Edge virtual machine with its disk and networking, the cognitive service and the IoT Hub. And there's this lovely delete resource group button just here.
Lovely.
What do you think that does?
Delete all the resources here, the object resource group.
Yeah. So this will delete the resource group and all 8 resources inside it. So as a sanity check,
Oop, you have mistake. Yeah. No.
You know what?
Are you sure that you want to delete?
I'm using a special quiet keyboard because I normally use a mechanical keyboard that's very loud, and I think this keyboard's running out of batteries. So type in the resource group name, and what this will do is this will delete all these services. So I click delete. That's it. That's done. That is now deleting. I can forget about this resource group. Once the virtual machine has been deleted, which will be done in a few minutes, I won't have to pay anymore. So this VM has been running for about 30 minutes, which is going to cost me a few cents. So this is not an expensive module to run. The hub was free, Text Analytics was free. So this is the important thing. Whenever you're not finished with a project, delete it. Because otherwise you could, if it's not using free services, you can continue obviously having a cost. If you are using free services, you're only allowed one. So you're only allowed one free IoT hub. So if I don't delete this, I can't create another one for a different project. So when you're finished, delete. So in summary, what did we do today, Marko? We talked about the scenario for detecting language from medical labels to use a disaster zone. We did this using a cognitive service, and we deployed it to IoT Edge so we could run it offline.
Yeah.
It's all done using this Learn module. So if anyone is watching this, if you want to do this yourself, if you want to try it out, go to aka.ms/learn/IoT Edge, and that would take you to this cognitive services module, and you can work through it all for free. All you need is the Azure subscription to spin up the resources that you need. It's pretty cool. Now, this is 3 out of 4 sessions. We have recordings of all these sessions available. If you missed any of them, head to these links for a whole lot of bits and pieces about IoT Edge. We're doing DevOps solutions or IoT with Azure Sphere, all done in collaboration with the University of Oxford. And that's it. We're done here. Thank you very much, Marko. Did you enjoy that?
Yes, I was very happy. Thanks to everyone who was watching this, going through the module. And I hope that in the future we will have more sessions like this.
I hope so too. I had a lot of fun with you, Marko. I really enjoyed this. So, thanks everyone. Thanks for watching, and have fun with Microsoft Learn.
Yeah. Bye-bye.
Bye.